Achieving optimal performance, the ideal conditions for a well-balanced pump. In the realm of industrial machinery, a pump operating under ideal conditions represents the zenith of efficiency, reliability, and longevity. This state, often termed positive synergy, arises when every critical factor influencing the pump's operation is meticulously optimized. Instead of acting in isolation, each of these conditions, or humors as they are metaphorically presented, mutually reinforces the others, culminating in a system that performs far beyond the sum of its individual components. Let's explore these fundamental elements that define this ideal scenario, illustrating how their harmonious balance yields unparalleled operational excellence. Humor number 1. Optimized lubrication and fluid management. The bedrock of healthy rotating machinery is its lubrication system. For a well-balanced pump, this means an oil reservoir consistently filled to the precise recommended level with the correct grade of lubricant. This isn't just about having oil, it's about the right oil, in the right amount, at the right time. The correct lubricant grade ensures optimal viscosity, forming a protective film between moving parts, significantly reducing friction and wear across various operating conditions. Too low a fill level can cause aeration, degrading the oil and impairing lubrication, while too high can lead to excessive churning, increasing temperature and energy consumption. Beyond grade and level, the lubricant's quality and integrity are paramount. Contaminants, such as water, air, or particulates, severely degrade performance, causing premature wear. Thus, an ideal system integrates robust filtration and regular oil analysis to maintain pristine lubricant condition. This diligent attention to lubrication ensures minimal internal friction, effective heat dissipation, and protection from corrosion, thereby extending pump life and reducing energy expenditure. Humor number 2. Flawless shaft alignment. Shaft alignment stands as a paramount factor influencing the lifespan and efficiency of rotating equipment. For a well-balanced pump, alignment is impeccable. During installation, the shafts connecting the motor to the pump undergo meticulous laser alignment, ensuring angular, parallel, and axial tolerances are within infinitesimal margins. This precision eradicates internal stresses that would otherwise manifest as destructive forces. Misalignment, even slight, induces excessive radial and axial loads on bearings, seals, and couplings, leading to increased vibration, premature component failure, and elevated operating temperatures. Energy loss due to friction from misaligned shafts can be substantial, directly contributing to higher current draw and diminished overall efficiency. In an ideally aligned system, power transmits smoothly and efficiently. Forces on shafts and bearings remain symmetrical and within design limits, allowing components to operate as intended. This minimizes wear and tear, reduces operational noise and vibration, and fosters a stable pumping environment. Regular alignment checks, even in ideal setups, maintain this critical condition throughout the pump's operational life, safeguarding long-term performance. Humor number 3. Impeccable contamination control. The battle against contaminants is critical in industrial settings, and a well-balanced pump achieves decisive victory. Filters and seals are not merely present, they are meticulously selected, properly installed, and regularly inspected and replaced to remain perfectly intact and functional. This creates an impenetrable barrier, preventing any ingress of dust, moisture, or other airborne debris into the system's vital components, especially the lubricant and bearings. Even microscopic particles act as abrasive agents, causing significant wear to precision surfaces, leading to reduced efficiency and premature failure. Moisture, furthermore, degrades lubricant properties, promotes corrosion, and can lead to hydrogen embrittlement in metallic components. An ideal system employs multi-stage filtration for its lubricating oil, and relies on high-quality, often non-contacting or labyrinth seals, supplemented with desiccant breathers, to protect against environmental contaminants. The integrity of these components ensures the pump's internal environment remains clean and dry, allowing the lubricant to perform its protective function unimpeded. This proactive approach to contamination control extends the life of both lubricant and mechanical components, significantly reducing the likelihood of unexpected breakdowns and bolstering overall reliability. Humor number 4. Optimized motor operation within design parameters. The electric motor driving the pump is its heart, and in an ideal system this heart beats precisely as intended. The motor consistently runs under its rated load and temperature, meticulously avoiding conditions of overheating or overloading. Operating a motor outside its specified parameters has severe consequences for both the motor and the entire pump system. Overloading, even briefly, causes excessive current draw, leading to increased winding temperatures, insulation degradation, and ultimately, premature motor failure. Similarly, operating at elevated temperatures, whether due to ambient conditions, poor ventilation, or internal friction, drastically reduces the motor's expected lifespan. A well-balanced pump system ensures the motor is appropriately sized for the application, with effective cooling mechanisms in place. Monitoring systems provide real-time feedback on current draw and temperature, allowing for immediate intervention if parameters deviate from ideal. This ensures the motor operates at its peak efficiency point, consuming only necessary energy and generating minimal waste heat. The stability provided by optimal motor operation propagates throughout the system, reducing thermal stress on couplings, bearings, and seals, and contributing significantly to overall pump reliability and energy efficiency. Humor number 5, robust structural integrity and foundation. The physical stability of the entire pumping unit, though often overlooked, is absolutely critical for ideal operation. In a well-balanced system, the pump baseplate is structurally sound, meticulously leveled, and securely anchored to a robust foundation. All mounting bolts are torqued to specifications and regularly checked for tightness, with no signs of cracks, looseness, or corrosion in the frame or surrounding support structure. A weak or unstable foundation acts as a source of destructive vibration, even if shafts are perfectly aligned. This vibration causes components to loosen over time, leading to misalignment, accelerated wear on bearings and seals, and even structural fatigue in the pump casing itself. A solid, stable foundation provides a rigid platform that absorbs operational vibrations and maintains the precise geometric relationship between the motor and the pump. This unwavering stability is essential for preserving shaft alignment and ensuring the pump operates smoothly without introducing additional stresses. Regular inspection of the baseplate, foundation, and anchoring hardware is a cornerstone of maintaining this ideal condition. By eliminating external sources of instability, the entire system can focus its energy on its primary function, ensuring maximum mechanical efficiency, extended component life, and a significant reduction in noise and vibration levels. The power of positive synergy. When each of these 5 humors or critical conditions, optimized lubrication, flawless alignment, impeccable contamination control, optimized motor operation, and robust structural integrity, are not only met but meticulously maintained, a profound phenomenon known as positive synergy occurs. Here, the individual benefits of each condition multiply and reinforce one another, creating a holistic system far more reliable and efficient than the sum of its parts. Eliminating friction through perfect lubrication means less heat generated, which reduces thermal stress on components and the motor. Perfect alignment minimizes vibration, protecting seals and bearings, reducing contaminant ingress, and preserving lubricant quality. An optimally operating motor puts less strain on the entire mechanical train, contributing to lower vibration and longer component life. A solid foundation ensures all these precise conditions are consistently maintained. The tangible benefits of this positive synergy are transformative. As the initial premise states, the pump runs cooler, draws less current, and achieves 3 times its expected mean time between failures. Running cooler signifies less energy wasted as heat and reduced thermal degradation of components. Drawing less current translates directly into significant energy savings and reduced operational costs. An increase in mean time between failures, MTBF, by a factor of 3 or more is a testament to extraordinary reliability, drastically cutting down on unplanned downtime, emergency repairs, and associated production losses. Beyond these, a well-balanced pump experiences lower maintenance costs, extended component lifespans, improved operational safety, and consistent, predictable performance, all contributing to a more sustainable and profitable operation. Conclusion. The vision of a pump running under ideal conditions is not an unattainable fantasy, but an achievable goal through diligent adherence to fundamental engineering principles and best practices. By meticulously optimizing lubrication, ensuring flawless shaft alignment, maintaining impeccable contamination control, operating the motor within its design parameters, and establishing robust structural integrity, organizations can harness the power of positive synergy. This holistic approach transforms a collection of individual components into a cohesive, highly reliable, and energy-efficient system. Investing in these ideal conditions pays dividends in increased longevity, reduced operational expenses, and enhanced productivity. making the well-balanced pump a benchmark for operational excellence in any industrial setting. It is a testament to how meticulous attention to detail in every aspect of machine care can unlock unparalleled levels of performance and reliability.